applications of initial value problems where we're given a derivative and some information, some initial information about our function, and we work backwards to find the original. Alright, so the first application is a profit example. Suppose a company knows its marginal, it says marginal cost, it's saying marginal profit. Alright, suppose the marginal profit for profit in dollars per item is given by this equation, the derivative of the profit, right? So this is the derivative of the profits. Alright, find the profit function. We know, find the profit function if we know when they sell no items, they will have a profit loss of $40. So that's my initial value. I know when x equals 0, the profit at 0 is a negative $40. Right? So that's my initial value. When 0 goes in, negative 40 should come out. Alright, so first I find all possible profits by taking the antiderivative of my profit. Alright, so all possible ones, well, it's 2.6 x raised to the add 1. So remember, 1.1 plus 1 is 1.1, but we're not done. We have to remember to divide by that. Let's see. That's an improper fraction. It's not the end of the world if you leave 2.6 over 1.1, but you should write it as a proper fraction, which would be 26 over 11. X to the 1.1 plus c. Then we know if I plug 0 in, I should get negative 40 out. And so I use that information. Negative 40 equals, well, I plug 0 in for x. That means that'll 0 out, which this one's kind of nice. 0 is always a nice one, with especially polynomials, because that usually means whatever the number that comes out. Not always, but usually the number that they gave me is my constant. And that is the case. Negative 40 is my c. And so the profit function is 26 over 11 x to the 1.1 minus 40. All right, so there's my profit equation. And then we use it. So usually what we do is we ask you to find the original function. We give you the derivative and a piece of information. And then we ask you to use it. Alright, so find the profit when they produce and sell 100 items. So that's my x value. So profit, and so this is just plug it into that equation you just found. Again, the units are, everything's in 1, so I don't have to worry about units. So it's just plugging in exactly as is. And so dollars should come out. So $4,676.07 if I round to penny. Will be the profit. Alright, next example. Marginal cost. So given the marginal cost, which is the derivative of the cost, is given by that 0.6x squared minus 0.2x plus 5, where x represents the number of tables. And it's dollar per. Alright, so everything's in dollars and tables. I don't have to worry about my units. What they are. If the total cost to produce 25 tables is 1,020, so there's my initial value. I know when x equals 25, that's my tables, the cost at 25 is 1,020. And so there's the information, there's my initial piece. Then they're asking me, the final part is, well, what's the cost when x is 30, right? What's the cost at 30? That's going to give me my final. But in order to find that, so instead of, unlike the last example where I did part A, find the formula, part B, use it, well, this one they asked it all in one question. You have to find the formula for cost in order to figure out how much it costs to produce 30 items. Alright, so my cost function first. So the cost function in general is the antiderivative of the derivative. Again, this finds all possible cost functions. I get 0.6 x cubed divided by 3 minus 2.4 x squared divided by 2. 50x plus some unknown, which is why they gave me that piece of information. Now before I get started, clean it up. Those can all be simplified, right? I can take my calculator out and I can take 0.6 divided by 3 and 2.4 and divide by 2 to get 0.2 x cubed minus 1.2 x squared plus 50. And it just makes the calculation a little easier. Alright, now I'm going to use this piece of information to find c. Alright, I know when I plug 25 in, it should come out 1,020. Alright, so 1,020 should equal when I plug 25 in for my x value. So I plug 25 in for my x value, so I get 25 cubed minus 1. And again, be careful. Alright, this one's a little bigger, and so there's a little more that you have to make sure you're careful with. So what I usually do is I simplify this side first. Alright, I take my function with the x value and I simplify. Alright, so my 0.225 cubed minus that, and so on. So 1020 equals whatever that number comes out to be. When I type it out on my calculator, it comes out to be 3,625 plus c. And then to solve for c, you have to subtract that number, 3,625. And the constant equals negative 2,605. And that's not my final answer. Again, that just means now I know what cost is. So I'm actually going to, or now I know what my c is. So I'm going to go up here and just replace the c here. I now know this is a negative 2,605. Right? And so there is my cost equation. And now I'm going to use it to get to my final answer. Right? My final answer is what's the cost at 30. Right? How much does it cost to produce 30 tables? So I take my x value 30 and plug it into this equation for cost that I now have. Alright, so cost at 30, and I'd be careful when I plug it in. So again, it's going to go in here as 0.230 cubed minus 1.230 squared plus 50 times a minus the 2,605. And when I do that, it comes out 3,215. Alright, so it cost $3,215 to make 30 tables. And that's my final answer. Alright, the last one, I believe. Alright, in a memory experiment, where is this? It's not in my way here. In a memory experiment, the rate at which a student memorizes Spanish vocab words is found by that function. So it's a derivative, right? Rate is how fast they learn them. Is 0.2t minus 0.003t squared, where m of t is the number of words memorized in t minutes. It's just in words and minutes. I don't have to worry about units. Alright, find m of t if it is known that if you haven't studied at all, you haven't learned any new words, right? It should make sense that 0 times studying, 0 words memorized, right? So that's my initial value. So all possible m of t's would be my antiderivative of 0.2t minus 0.003t squared with respect to t. Alright, so 0.2t to the second divided by 2 minus 0.003t cubed divided by 3 plus c. Simplify that. Alright, 0.1t squared minus 0.001t cubed, right? It simplifies nice. And then I know 0 in should give me 0 out, which that means that's what c is, right? If I plug in 0, well that 0's away, that 0's away, so that's 0 plus c. So that means c has to be 0. Alright, that's kind of a nice one. So again, you can kind of just erase the c, it's 0. Alright, I'm going to rewrite it down here. 0.1t squared minus 0.001t cubed. And you don't really put the plus 0, even though that's what c is. Alright, so there is my function. There's the words memorized over t minutes. And then they usually ask me to find something. So there's part A, find m of t. How many words are memorized in 8 minutes? So you take 8 and plug it into that new equation. Right, so that's A. B is find m of 8. So again, I'm just plugging 8 in there. It comes out 5, 8, 8, 8. I'm around to 6. So in 8 minutes, they learn or memorize about, since I did round, 6 words in Spanish. Alright, we'll stop there. So that finishes up 4.1. So the biggest thing is just practice the rules. And remember, antiderivatives, integration, working backwards. Alright, I'm going from a derivative back to the original. If I don't have an initial value, I find all possible ones. Right, that's what the plus c is all of them. And then if they give me a piece of information, they give me an initial value, then I can find the specific c value I'm looking for. And those are the when we apply it. So those are the applications. Alright, so that finishes up 4.1.